Several videos ago, I alluded to a project that is one of my absolute favorite to give new students or people who are starting to come into the digital logic world. And that is setting up the basic logic for not even a full thermostat where you have the fan, the cooling, the heating, just a cooling circuit. And watching them put together the what everybody eventually arrives to, and then jumping up and down going, "You fool! You have absolutely blown up your compressor! Fail!" Also, let's talk about how you failed. Hello, welcome to Chaos and Controls, a show where we talk about modern devices, technologies, and techniques for automating your home, business, or life. I'm your host, the Automation Doctor, and today I'm going to show you how not to blow up a compressor. So let's go ahead and start and talk a little bit about an HVAC circuit and what I'm trying to do. And let's say that I have a room that I want to maintain at a nice 72 degrees Fahrenheit, because Fahrenheit is for humans and Celsius is for water. I, for one, although being made mostly out of water, prefer the human route. Also, for the record, I do have a true engineer's handwriting. My 7s have a line through them, and my Z's also have a line through them, as opposed to my greater than symbols that do not have a line and my 2's that do not have a line. I apologize. I know. I've been working on it my whole life. For the record, I've also got a neurological disease, so bear with me. Thank you. In any case, I am trying to attempt to maintain a room at 72 degrees Fahrenheit, and I tell people that what you have is a temperature probe and a simple output of whether or not it is time to deploy cooling. And invariably, people come up with the basic circuit of something to the effect of, if I were to make this in ladder logic, now most ladder logic in the modern world actually represents something closer to function block, where you have different blocks that do things. And I could say something to the effect of, and I say it's 72 degrees, but let's go ahead and say that I gave you I still can't spell, a set point. And so generally, in most ladder logic, you are going to have a compare block of some sort. And you can get outputs of this. It's true if true and false if false. And we'll say that if temperature is comparatively greater than set point, make that true. And then you'll go ahead and take this over to the cooling coil. And ta-da! This is what everybody comes up with. Congratulations, you just blew up your compressor. Get out of my facility. And the reason for that is because you're going to get to 73 degrees, or 72.1, or however tight you're trying to keep this tolerance. And we're going to creep up and hit that and immediately turn on the compressor. And after just a very little bit amount of time, we're going to drop back below set point. And the compressor turns off. And then it heats up, and we turn on, and cools off, turn off, on, off, on, off, on, off. And as it turns out, compressors don't like to be turned on and off rapidly. Some things you can. Most things like to either be running or not running. So let's go ahead and talk about, well, how could we solve this so that we don't end up blowing up our compressor? As it turns out, there is a concept called hysteresis. And for the record, I've probably spelled that wrong. All right, well, jumping back into that, I had to deal with a phone call, so I honestly don't know if I'm keeping the bad takes in these or not. We'll see what people like. So we have this concept called hysteresis, and it is fairly commonly misunderstood. And all hysteresis means is that if I have some sort of a chart, and we have something happening, the direction that I take going this way is different from the direction I take coming this way. And I know that sounds kind of weird, but we can translate this into our start-stop circuit, our cooling circuit here, by basically stating that if this is my set point, then I want to turn on cooling somewhere a little bit above set point, but I want to turn off cooling somewhere below set point. And that way, I don't end up turning on and off at set point, and I on, off, on, off, on, off. And so, just to make whole numbers, if I'm trying to maintain 72 degrees, the way to do this would be, say, that at 73 degrees I turn on and at 71 degrees I turn off. And now we wait just a little bit, it turns on, and we start cooling, and it usually takes a few minutes to get past, a couple of degrees, sometimes even longer than that, depending on how much you're losing the thermal war. And so typically this gives you at least a few minutes of time to save your compressor. And as a rule of thumb, you do not want your compressor to run a full cycle in less than 5 minutes. That is generic rule of thumb, really depends on the equipment that you're running and everything else, and there's a lot of nuance that goes into that, but for the most part, even small stuff doesn't like to be run more than every 5 minutes. So in our ladder logic circuit, we could do something to the effect of, if my temp is greater than set point plus some offset delta, we are going to what we call a latch. And all that means is that once I turn it on, even if I turn this signal off, it stays latched on. And I'll have another comparator block. If my temp is less than, comparatively, my set point minus some temperature delta, then the opposite of a latch is an unlatch bit. This is much more likely to save your compressor. There's one more thing. We said that we want to include that our cycle is not less than 5 minutes, so we might also add a couple of timers into this. But again, for the most part, if you're going more than a degree or so, you're probably going to be okay on a compressor. Personally, I would add in some timers, but that's getting a little bit more advanced for a video this long for how we're going to talk about it. We'll definitely be talking about timers and why they're useful and how to use them in various situations, but this is the quintessential HVAC problem that I like to give new students who fail and blow up their compressor, and then they learn. That's about all I have for you today. You all have a good one, and I will catch you next time.